Assalamualaikum and a very good day. We are from 3 BMMA Section 1/2, Group B. Our topic for engine technology assignment is VANOS plus turbocharger. So my name is Iskandar, matrix number B091910206.
Okay, my name is Firal. Matrix number B091911037.
Okay, my name is Afifah Binti Adnan. My matrix number is B091911088.
My name is Ling Pei Shi and my matrix number is B091910294.
My name Muhammad Shazmin bin Ahmad Firal. My matrix number B091910106.
So today I would like to present about the introduction and history of VANOS and turbocharger. VANOS engine is a variable valve timing system used by BMW vehicles, and the word VANOS is an abbreviation of German words which called as variable no valence theorem, or in English we also can call it as variable camshaft timing. So basically this system is based on the solenoid, oil and helical gears. And there were two types of system was introduced, which is the single VANOS and the double VANOS. Single VANOS is the most earliest systems, and it used to adjust the position of the intake valve only, while the double VANOS was used to adjust the both intake and exhaust valve individually. Turbocharger is content of turbine, air compressor, and has snail-shaped housing appearance. So the turbocharger is make use of wasted exhaust gas from the exhaust manifold to pull more air into the intake valve to produce more power in the engine. So there is two main ports, which is the inlet port, which allowed the high pressure exhaust gas to enter into the system, while the outlet is pass out the high pressure compressed air into the engines. The first turbocharger was invented in the early 12th century by the Swiss engineer Alfred Bucci in prototype form, while in 1962 the first turbocharged production car engine was used in Oldsmobile turbojet fire. Okay, that's all from me. I would like to pass my presentation to next team member.
Okay, I will explain about theory of operation for VANOS. VANOS gear is totally ideal has no effect on valve timing. The solenoid is actual when you step on the gas pedal and begin moving through the RPM range, forcing oil through the system. The VANOS gear begin to insert itself between the cam gear and the cam as the oil pressure. As a result, the intake and exhaust valve position overlap, allow for exhaust gas recirculation, an activity that reduces emission at highway speed. The VANOS gear gently recat wherever the engine reaches a high RPM range. The overlap between intake and exhaust valve is minimum, as the result allow for more power. So next. Theory of operation for turbocharging. A shaft having a turbine wheel on one end and a compressor wheel on the other make up a turbo. These are protected by snail-shaped casing with a intail part through which high pressure waste exhaust gear enter. The turbine rotation as the air travel through it, and the compression spin with it, suck in the mentioned amount of air that compressor and release without the outlet part. An intercooler, the compressor air before it reaches the cylinder, and a pipe feed is back into the cylinder because turbo pin at such high speed up to an oil cooling system is usually installed to keep them cool. Most systems also have a wastegate valve, which is used to drive a supply gas away from the turbocharger when the engine produce too much boost, limited the turbine rotation speed and prevent damage to the turbine. So that's all for me. I will pass to next member. Thank you.
Okay, so I will explain about the VANOS system diagram. So as Ira has explained about how the theory of function. So for VANOS system, especially for the single VANOS and the double VANOS, the differences is that double VANOS has an operation to adjust the cam timing for the intake and the exhaust. So as we can see, the way of deactivation method is that the advanced piston move in, which is for the exhaust camshaft. So the exhaust side camshaft is advanced so that there's a overlapping for the exhaust valve and the intake valve. And once the VANOS has been activated, the advanced piston moves out for the exhaust and the intake retard pistons move in. So now that the timing for the intake has been adjusted from being at a retard timing to advanced timing. So once that has been done, now that the engine reads that the RPM change from low RPM to high RPM, where it changes from saving fuel to now making more higher end power. So that's why the differences is that advancing the timing from the camshafts changes the way that the engine functions for its intake and exhaust gas scavenging. Okay, next. Now, for the system that used in most of BMW's twin power system, which is the VANOS and turbochargers, they use a twin scroll turbo. So the reason why it's a twin scroll turbo is that the twin scroll turbo has two vane side on the exhaust turbine housing. So the first vane is from cylinder 1 to cylinder 4 is where it's only for high velocity airflow. So this only makes the turbo becomes very responsive on low RPM. Then for cylinder 2 and cylinder 3 is for the high air capacity, which is for the high end vane side, which is, as you can see, the orange color. So that is for making the turbo spin much faster throughout the mid-range to the high-end range of the RPM, so that the turbo's efficiency of working is at optimal range. Now, this has the biggest benefit because of it's able to be very efficient on low RPM and very high power on high RPM. So the BMW twin power system uses a twin scroll turbo rather than a single scroll turbo. Okay, thank you. I will pass to my member.
Okay, next I will talking about their advantage and disadvantage. First of all, I will talking about VANOS system. Firstly, the advantage is lower exhaust emission, which reduce the pollution to the air. And next, increase fuel economy. Next, optimize torque and power across reference, which this condition happen when the engine RPM increase the valve open earlier. So this enhance torque as RPM increase. Plus, for the advantage, which improve idling quality and smoothness. For disadvantage of VANOS system, firstly, it will lose of power in lower RPM range. And next, an engine will hesitate and work at lower RPM. Third, increase in engine misfire. And lastly, it will have lack of variable lift and variable valve opening duration, so less torque and power. So for the next turbocharged system, firstly, the advantage is increased horsepower of engine. And next, allow for smaller engine displacement to produce much more power relative to their size. And next, better fuel economy, which when we have smaller engine, So it will use less power, less fuel to idle and have less rotational. Also, reciprocating mass which increase fuel economy. And last, for the advantage is higher efficiency, which turbocharge, it uses waste hot gas to compress air, which increase thermal efficiency. As air goes in the engine, it will increase volume of engine and will help in better fuel burning and more power cycle. So then for disadvantage, turbo will have lag because it takes time to spool up and provide useful boost. And next, boost threshold, which they typically do not operate across as wide an RPM range as supercharged. And next, power surge. In some turbocharged application, especially with larger turbo, reaching the boost threshold can provide an almost instantaneous surge in power, which could comprise tire traction or can cause the car instability. Lastly, for disadvantage for turbocharged is need more fuel because turbocharged will get very hot and they frequently drain the engine oil supply, and because of that, it needs more engine oil. So next, I will pass to the next presenter.
Okay, for conclusion, number one, BMW has employed the VANOS variable valve timing system variety of petrol engine. Number two, variable Steuerung is an acronym of the German word for variable camshaft timing. Number three, turbocharger is a turbine-driven forced induction device that boosts the power output of the internal combustion engine, delivering more compressed air into the combustion chamber. So we can conclude where advantage and the disadvantage between two engine systems. So we can choose between both or one of the engine according to the budget and suitability of the user. Okay, that's all for me.
Okay, that's all for our group. Thank you.